Welcome to this video on steam locomotives in the Harz region, tracing their path from mining pumps to tourism. We will explore their history, technology, and heritage. Our journey begins with the steam locomotive in the Harz, a technology that evolved from its early use in mining to a key component of the region's tourism. What is a steam locomotive? It is a traction vehicle powered by water vapor, produced in a boiler mainly heated by coal combustion. This energy is converted into mechanical movement of the driving wheels. Mining pumps, the technology that started it all. Flooded mines were a major problem in the 17th and 18th centuries. The solution was the steam pump, exemplified by Thomas Newcomen's 1712 machine, where steam moved a piston to operate the pump. James Watt, a Scottish engineer, made crucial improvements, including the speed regulator. This mechanical device automatically regulated the machine's operating speed without human intervention, ensuring safe and stable steam use. George Stephenson, a pioneer of steam railways, created the rocket in 1829 for the Rainhill trials. The objective was to find the best locomotive for regular service on the Liverpool-Manchester Railway. The rocket introduced key technical innovations, such as the smoke tube boiler for greater heating surfaces, the blast pipe for better draft and combustion, and direct drive to the driving wheels for less energy loss. The rocket achieved a maximum speed of about 45 to 50 kilometers per hour, weighed about 4.3 tons, and used coal as fuel. These were revolutionary performances for the 1820s. The historical significance of rocket is immense. It won the Rainhill trials, set the constructive model for steam railways, and proved that rail transport was safe, efficient, and profitable, ushering in the era of modern rail transport. Coal formed millions of years ago from plant residues under pressure and heat. This process transforms peat into lignite and finally into hard coal. Coal became a key fuel for steam engines and industry. The evolution of extraction technology involved a shift from manual mining to mechanical hammers, steam pumps for mine drainage, and the first mining railways for coal transport. This improved accessibility and lowered raw material costs. Coal processing includes sorting for quality, drying, and sometimes pre-carbonization to produce coke. Coke was an essential fuel for metallurgy and heavy industry. High-quality coal with a high calorific value was required for steam locomotives and industrial machines. Comparing calorific value, lignite is 12 to 20 megajoules per kilogram, hard coal is 24 to 30 megajoules per kilogram, and crude oil is 42 to 46 megajoules per kilogram. In the 19th century, coal was more economical and readily available than oil, despite its lower calorific value. Major coal extraction centers in the 19th century included Great Britain, Germany, the USA, and the border regions of France and Belgium. These areas fueled the development of steam railways and manufacturing industries. Coal was the ideal fuel for steam locomotives due to its high calorific value, which generated powerful steam. It was also easy to transport and store in stations and wagons, and readily available across Europe and America in the 19th century. Steam locomotives enabled fast transport of coal from mines to cities and factories. This led to the first dedicated coal transport railway line. Local mining railways created efficient links between mines, steel mills, and ports. Steam locomotives accelerated industry and increased the availability of raw materials. The steam locomotive was significant for the Industrial Revolution. It provided a stable energy source for factories and accelerated trade and urbanization. The combination of coal and steam propelled modern industry. Examples include the UK's Lancashire, Germany's Ruhr Basin, and local steam locomotives in Harz transporting coal to foundries and factories. The Harz Mountains presented a difficult terrain with steep slopes and narrow valleys, limiting space for railway lines. The challenge was building tracks and adapting locomotives to the mountainous topography. Special technical solutions were required for the Harz Mountains. These included narrow-gauge locomotives, reinforced boilers and brakes, and special wheels or ab-track systems for better uphill traction. These technical adaptations ensured the safety and stability of steam locomotives, allowing them to operate effectively in the mountainous conditions while transporting goods and passengers. The Harz Narrow Gauge Railway is a mountain railway network spanning over 140 kilometers of tracks. Steam locomotives have been in use from the 19th century until today, serving both freight and tourism. The Harzer Schmalsperbahnen, or Harz Narrow Gauge Railway, is a living museum of steam railway transport, preserving this crucial part of industrial history. The Harz Narrow Gauge Railway is an important tourist attraction, offering scenic routes and a glimpse into the region's industrial past. It represents an efficient adaptation to the difficult terrain. In conclusion, the steam locomotive was a driving force of the Industrial Revolution, evolving from a mining tool to a symbol of transport efficiency. The Harz Railway is a unique example of technical adaptation. Thank you for watching this video. We hope you enjoyed learning about the history and technical aspects of steam locomotives in the Harz region.